Let us now have a look at one potentially very useful function of Excel and R, and that is the generation of random numbers. As you may recall from our discussion of experimental research design, randomness may be a very useful thing. Often, we want to make sure that we are selecting our cases, the cases we study, not on the basis of some preconceptions or conscious or subconscious criteria, but neutrally. And pure randomness is, in this sense, the best neutrality guarantee, as randomness, by definition, does not take into account anything. It turns out that generating truly random numbers is, mathematically speaking, not exactly easy. So we often speak of pseudo-random numbers rather than random numbers. But for our purposes, these pseudo-random numbers we will generate are as good as truly random numbers anyway. In Excel, random numbers are generated with the command called rand, random, with brackets attached to it. Type into any cell in Excel the formula is equal to rand and brackets, and you will get a random number between 0 and 1. So why might that be useful? Suppose that you had a list of 10 observations called A, B, C, D, E, F, G, H, I, J, and you wanted to select from them randomly, so to make a random selection out of this population. One easy way to perform such random sampling is to assign to each of these observations a randomly generated value, order the observations by these values, and then pick, for instance, the first 3. So let us create in the column adjacent to the observations random numbers with our command rand. Now, these random numbers will keep changing anytime we do something in Excel, so we may want to fix them. It might be wise, therefore, to copy the whole data selection and paste it while selecting under the paste special option only values. And you will see that the rand command, which we had here, is not present here anymore, and we have the raw numbers instead of it. Now we can simply sort the random numbers by their order, going to data ribbon, and remember to expand this selection. And now here we have randomly ordered numbers, randomly ordered letters or our observations. A stayed on the first place just by coincidence. It's pure chance that it has happened. If we select the first 3, we know that these first 3 numbers were selected randomly because these numbers, the values adjacent to the individual observations, have been created randomly. So we have a random sample, so A, B, and F is a random sample out of our original 10 variables. And note that randomness can indeed lead to surprising outcomes or to outcomes that are not expected, because the first 2 letters we had that stayed were A and B. So by pure chance it can happen, although it's extremely unlikely that the first 2 values of our sample actually stayed the same. So that's rather simple, isn't it? Now in R, to generate random numbers, we will need a package and library called SM. So please install and load it with your known commands install packages and library. Also, please install and load the package called sfsmisc, again sfsmisc, which we will use later on. You can also do it right away. So in R, to generate, let's say, 3 random numbers, between values 0 and 100, we can use the command runIf, standing for random uniform. As options in brackets, we identify first number 3, because we want to create 3 new numbers. And then we identify the minimum of the range and the maximum of the range from which we want to select the numbers. Note again that this command runIf draws these 3 random numbers from uniform distribution, so a distribution in which every single number has an equal chance of being selected. We can create the new variable called R1, which will have 3 values, and all of them should fall. You can have a look at it. All of them should fall in the range between 0 and 100. And here we have the value 71 plus something, 94 and 59.8. Now, as I said, uniform distribution is such distribution in which all values have exactly equal chance of being selected randomly. Now, this is very different from the normal distribution, where extreme values have very low chance of being selected, and values close to the middle of the distribution have a high chance of being selected. And to create a list of, say, 1000 randomly selected numbers that follow normal distribution, we will use the command rnorm for random normal distribution. And in the brackets, we will give our 3 values. First, the number of observations we want to create, so number of random draws from a normal distribution. And we will give it the value of the mean of the normal distribution or the normal distributed data and of the standard deviation. So let us set the mean of our hypothetical parent population at 100 and standard deviation at, let's say, 20. And a new object or variable called, for example, n1 will be created. And it will contain 1000 numbers that were randomly selected from a population with these properties. So that follows normal distribution, has a mean of 100 and standard deviation of 20. See that a new object was created here. You can have a look at the object, and it's 1000 numbers, where all of them should be somewhere close to 100, and some of them should be further away from 100, but only a few of them. You can check that the mean of this new variable should be somewhere close to 100. It was a random process, so it is unlikely that it would be exactly 100, or technically speaking, it's almost impossible, but it should be rather close. So let's have a look. Oh, and we see that the mean of these 1000 values is 99.84. And the standard deviation, we have set it at the beginning that it should be that the parent population should be somewhere, should have a standard deviation of 20. So the standard deviation should be around 20 here. And we can see that it's 20.68. So indeed, the true descriptive statistics of our randomly generated variable are close to what we have set for the random generation process in the first place. So in sum, we can easily create variables with any number of values. And these values can come from a uniform distribution with the given range, so e.g. 0 to 100, or whatever, -7 to 12, or any values you can think of. And we can use the command runIf to get such numbers. And it may be whatever number of random numbers. Or we can also use randomly, or we can generate randomly data that will come from normal distribution which is defined, as we know, by its mean and by the standard deviation. So here, with the uniform distribution, the distribution was defined by the minimum and maximum. The normal distribution is defined by its mean and standard deviation. And the mean can be, for example, 0 or 127 or whatever. Standard deviation can be 1 or 20 or anything. And the command rnorm will be used to achieve that.